Okay, so last time we introduced vectors. So for our course, we focus on the two-dimensional vectors. 2D has two components. In the future, you will learn 3D, three components, and higher dimensional.
Yeah.
Mhm.
Wait, what
In the
about
future, you will
4D?
learn the,
What about 4D?
okay, it's possible, but we will not focus on it now. So we will get ourselves to the 2D, and in the future, we will deal with 3D, 4D, maybe 100 dimension.
I see.
Hmm. Okay. Give a vector. Amy, we have the norm. Okay. Okay, Aaron, what's the norm of this vector?
Root A squared plus B squared root.
Okay, nice. There's a different way to represent the norm. We have the dot product. Okay, so let's suppose that component.
Wait, what's U?
Okay, I'm going to write down, let's say x1, x, y1. Different v, because want to be similar, x2, y2. Then we, okay, Jessica, what's the definition of a dot product of these two vectors?
Could you say it again?
What's that?
Can you repeat that?
Okay, so for these two vectors, how do we compute the dot product?
Uh, um, I forgot.
Okay, Amy.
Um, so I think you do like x1 times x2
Mm-hmm.
and y1 times y2.
Then what's next?
Um, do you like add them or is it
Okay, that's the key point. We have to add them. A common mistake, as we mentioned last time,
oh, so you can't like put it as it's not like a point,
it's
right?
not a
Yeah.
vector. Mhm. I'm going to put a mark over there that's incorrect. Okay, so the point is the dot product is a number, a scalar. That's one way to find the dot product using the uh, call it the components. A second formula, let theta be the angle. Two vectors. Then the dot product satisfies uh, the dot product is the product of the three parts: norm of u, norm of v, and cosine theta. We will skip the proof we proved last time, so you can go back to check why it is this. not only you know the formula, but you know how to prove it. The key step, I just give you the key step for this, is the law of cosine. I can draw a picture of this. Two vectors, u and v. We want to prove the result of vectors. We need some result about the triangles. Okay, this is a very useful formula. We can apply it in two directions. First direction, George, let's turn the camera, George. Okay, so we can use the dot product to find the cosine theta. So given any two vectors, we can find the cosine of the angle between two vectors. Let's have some example. Okay, let's find the cosine of the two angles of the two vectors. Find cosine theta. Okay, give you a few minutes to find it out. You can enter your answer in the chat. In the chat, let me check. Okay, George get a 0. What does that mean? Okay, George, how do you get a 0?
Wait. So first of all, these things are on a line. There's no angle for a line. Like 1 and 2 and -4, 2, it's a straight line. The
Okay,
angle
okay,
is 0. So cosine
Amy.
is 0. Sine is 1.
Yes, Amy.
Okay,
Amy,
never
you want?
mind. You
Okay,
can
okay.
Or you can use the rule of A vector times B vector over the two outside line A and two outside line B, and you will get 1 times -4 plus 2 times 2 equals 0. And you use 0 divided by something, obviously that's 0. Or like on the fan, whatever you call it. So you eventually get like 0 divided by 10.
Okay, so this is our figure. What we have is this formula, cosine theta u dot v u v. Okay,
Oh
so we
wait, I
first,
see why it's not a line, but I'm still correct, right?
okay, yeah, still correct. Okay, so George, what's the dot product?
So you should get 1 times 2. No wait, no. I think this is when the time you use like the distance formula. Use 1 times -4 plus 2 times 2
Yeah,
over,
that's
that's
0.
just 0. That's just 0. Over like you don't even care over what. The answer is gonna be
Okay, okay. We don't care what this is. We know it's not 0, so this is 0.
Wait,
Okay,
how are we
cosine
sure it's not
is
0?
0. What does this mean?
Oh, that means sine equals 1.
Okay, what can you say about the two vectors? What can you say about the angle between them?
That's their equilaterals.
No, no, no. Okay, which angle has the property that cosine is 0?
AC over AB.
I mean, cosine of some angle is 0. What was AC and AB?
One side will be 1 and one side will be 0. The longest side will be 1 and the other side will be the vertical side will be 0 and the linear side would be 1, right? But
Okay,
I, I don't think this diagram makes any sense.
so,
Because cosine theta doesn't look like 0 to me.
okay, see, if if theta is 0, what's cosine 0?
Cosine 0 is undefined, I think.
Amy, cosine 0.
1, I think.
Okay, so at least we know this angle is not 0 because cosine 0 is 1. We get 0 here.
Wait, teacher, so does that mean that this weird thing you draw is in triangle, since in this case sine is going to be 0?
Okay, if
So
cosine theta is 0, what's sine theta?
0, sine theta is 0.
That's gonna be 0, I think.
What do you mean?
I
Both
mean,
cosine and
cosine
sine
is
at
0 degrees.
0?
No, the
Yeah.
teacher meant sine theta, not sine 0 degrees.
Oh, sorry.
Sine theta is going to be 1.
Okay, so here, this means theta is have 2, or you see 90 degrees. In this sense, we see the two vectors, they are perpendicular. Okay. So we have the following observation. Two vectors, they are perpendicular. If and only if the dot product is 0. Whenever you have a dot product of two vectors is 0, the two vectors have to be perpendicular. An intermediate step between them is
Teacher, what is
theta is,
vector in Chinese?
okay, in Chinese, it's called 向量. Okay. Now let's check another pair of vectors. U. Let's find cosine theta. Jessica, are you working on it? Find cosine theta. And George, turn the camera.
I have an answer, but I don't know if it's right.
Okay, yes. Oh, Amy, what's your answer?
Is it like 7 over 5 plus square root of 2?
That's kind of what I got.
Okay, but she said plus.
Yeah.
What
I got
times?
7 over 5 times.
Oh, okay, okay. Times. Right, okay.
Okay, yeah, okay. Be careful. So the denominator is the product of the two norms
It's
because
kind of
in
like the
our
oh my
formula
bad.
here, they are the product.
It's kind of like the descent formula divided by a bunch of weird ass numbers.
Okay, stop that.
You know, is there any need to swear in a math classroom?
That's just not a swear word in my.
No, he wants to be cool, okay, but it's not
Ah,
cool.
come on. Like everyone wants to be cool.
You don't want to be cool. Okay, you will see normal words. Okay, so cosine theta, again by the formula u dot v norm, my v is bad, norm, the product. Okay, dot product, so this will be 3 times 1,
That's 7, I
4
think.
times 1, yes.
And then
This will be
that's like root 5 times root 1, which equals 5 times. Well, no, 5 times 1, yes. Root 25 times root 1 equals 5.
okay, so this will be 7, 5. Okay, now let me check with you. The cosine is a positive number. Is this a right angle?
Yeah.
This is the right
Wait. No.
why?
Um, because if it's like uh
Because cosine theta is not 0.
oh yeah, okay.
If theta were parallel to 2, cosine must be 0. Okay, George, stop. Okay, stop text. Okay, only answer questions. No chatting. Okay, now what can we say about this angle? We know it's not a right angle. Is it obtuse or acute?
Wait, teacher. What do you mean by sine cosine theta is not 0?
So since, not a sine, since.
Oh, yeah, since cosine theta is not 0, theta can't be pi over 2, which is 90 degrees. Yeah.
Okay.
Yeah.
We know it's not parallel to 2. What can we say about this angle?
It has a
Cos
root on it.
Teacher, I'm raising my hand.
okay, George.
So, since we know, like, if it's bigger than 100, no, if it's bigger than 90 degrees and smaller than 180 degrees, theta is going to be negative, and if theta wants to be bigger than -1, but, like, smaller than 1, it has to be 0 to 90 degrees, so we can say that theta is smaller than 90 degrees, but bigger than 0 degrees.
Okay, so
Sure.
for cosine to be positive, theta it has to be an acute angle. Okay, next one. Let's find cosine theta and determine if the angle is acute, right angle, or obtuse. Okay, George, do the computation. Do not on your paper. George, get a pen and get a pencil, get a paper.
I have my answer.
Okay, Amy, what do you have?
Cosine, I was gonna say cosine equals
Okay,
negative
Amy is
1 over 5 root 2.
Yeah, that.
okay.
So
So
obtuse, right? Yeah.
okay, so it is 3 minus 4.
Yeah, so it's bigger than 90 degrees, but smaller than 270.
180.
Oh, yeah, smaller than 80. What the fuck
Okay,
did I say
so
270?
obtuse angle. So the summary.
Wait, what about those in like 270 degrees sections parts? What about those?
Okay, let's check.
Oh, 270, I think it's just like sine is negative.
Okay,
Yes, but like, would it be described as something else besides?
I'm not sure. I'm actually not sure.
okay, Aaron, what's the
Yeah?
angle between these two vectors?
That's a 90 degree?
Okay, if you go over there, you see 90 degrees.
Mm-hmm.
What if you go
That's
over
like,
there?
that's 270.
270. So
Mm-hmm.
normally we pick the smaller one. We call this the angle between two vectors. We do not call
Oh,
this
so
one.
that can also be used as a 270, I see now.
But we could, but we rarely use this angle. We
Okay, I see.
okay call this. Okay. So in particular, for any two vectors, the angle will be between 0 degree and 180 degrees. Or we
Yeah.
use 0 the radian. Okay, the summary. U dot V, the dot product. If it's 0, we know that they are perpendicular. If it's positive, then we know they have acute angle. If it's negative, the theta is obtuse. Among the first and the last cases, there's another special one when theta is 0. Okay, let me run over there. If theta is 0, what's the cosine theta? George, cosine 0.
So, what is sine?
Cosine 0.
Theta is 0, cosine 0, that's 1.
Okay, nice.
Right?
If this is 1, we can see the dot product of the two vectors, u, v, and the cosine theta. But the cosine theta is 1.
So UV is just UV.
Yes. In this very special case, the dot product is the product of the two norms. It's
What is
because,
what is the expression of this norm again? Isn't that just like itself?
so it means these two vectors have the same direction.
I just want to remind me like what does norm U mean in this case? I know what like
Okay,
double line. I know what the double line norm mean. I don't know what the single line norm is.
okay. So some textbook they use double line, some use one line. They're both common.
Oh, they're both the same. So
But
U
they're the same.
squared. So the square root of them is just themselves, basically.
What do you mean?
The square root of U is just no. The square root of the norms is just themselves. So
No. Square root of norm square is norm.
yeah, that's
Okay, write it down. If you have anything, write it down. Write it down.
yeah.
Okay.
Wait, can I just go back down? Because oh, never mind.
Uh-huh.
I thought I missed something.
Okay. Another case, this is pi. Cosine pi. Okay, think about it. What's cosine pi? Cosine 0 is 1. Cosine pi over 2 is 0. Cosine pi is
I think it's -1, I think.
-1.
Oh, okay. Yeah.
Okay, if this is -1, what can we say about the dot product? Amy?
It's the opposite, well, like negative of the
Mhm.
norms.
Okay, in this case, the dot product is the negative of the product of the norms.
Uh-huh.
They have this opposite direction.
Wait, teacher, in that case,
Mhm.
wouldn't that be wouldn't that be mean that the vector u and vector v has to be negative? Because the square root of something, if in case it's not imaginary, it has to be like positive.
Okay, so the norm, they cannot be negative. They are the square root. It cannot be negative. The
Oh, or else
dot
they'll be
product
imaginary.
can be, okay, we will use this later. So here, the dot product may be positive, may be negative. It depends on the relative position. Let me give a picture of this one. It will be like this. One vector, another vector. Oops.
Wait, aren't they opposite directions? Oh.
Okay,
Oh.
I'm drawing another one.
Hmm?
So I call this UV.
They're the same
This
direction.
one, U. Two vectors, if they have the same direction, the dot product is the product of the norm. If they have the opposite direction, the dot product is the opposite of the product. Okay. Next, we will recall something you learned in algebra, the slopes.
Oh yeah, it's like
Oh, I think you talked to us in like the
talked to
Saturday
this about
math class.
last time, like 2 weeks ago.
Yeah, that was like pretty weird.
That's like changing y over changing x, but like
It's
it
like
depends
kind
on
of
how
like
much.
yeah. What Aaron was saying.
Uh,
Like y2 minus y1 over x2 minus x1.
yeah.
Okay, so we all
Well,
know
okay,
the
let's explain the
slope.
opposite direction. That's different.
Okay, let's have the following example. The example 4. Consider the following points. First point, 1 and 2.
Wait, isn't it
Second
x2 minus
point,
x1? Unless I'm really thinking this wrongly.
Wait,
okay,
wait. Is it supposed to be y2 minus y1 over x2 minus
Yeah,
x1, or is it?
yeah.
okay, yeah, you are right, you're right, you're right.
I figured something was wrong there.
You are right. X2 minus X1. Okay, okay, tell me what the slope is for these 2
Un
points.
Undefined.
Why?
Well, that's because it's 1/0.
Yeah.
Well, but technically it's just 0, but like yeah, it can be undefined as well.
And also, if you think about it, if they have like the same x coordinate,
Uh-huh.
it's the same. So,
Okay, so how do we describe this line through P1 and P2? X1, 2.
Ow.
Okay, see, it's a vertical line. The slope does not exist. Okay, so to describe lines like this, we introduce the direction of the line.
Oh, so I remember in like sixth grade or something when I asked my math teacher, I was trying to like troll her and ask her like, what's the slope for a line like this? Is that like 0 or is it 1? She says, no, you're gonna learn about later. I was like, I thought she was joking.
Sorry for that.
Okay, so suppose you have 2 points.
George, what are you doing?
Asking me my father for inspiration.
You could just have left your phone there,
Oh, my phone is right here.
Oh, wait, then what is that?
That's my computer. I'm on a computer.
Oh, well. Wait, teacher,
Yes. Uh-huh.
I have a question. Is this gonna be used in vectors? This whole simple algebra thing?
What do you mean?
Like, you're teaching us simple algebra right now, so I'm just saying, are you gonna be, this is gonna involve vectors, right?
Okay, okay, give me 1 minute. Let me finish this. You will see the vectors.
Okay.
Okay, so we draw a line. We mark 2 points. Okay, okay, so we have a vector over there. Use different color. Okay, Aaron, you want the vectors. What are the components of this vector?
Hold on.
Okay, 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 okay. Maybe you do later. Amy first. We have these 2
um,
points.
You use the distance formula?
so, uh,
Mm-hmm. How do we go from P1 to P2?
I do
Okay,
not
okay,
know.
okay. George is waiting. Okay, George.
You use x2 minus x1 and
Okay.
y2
The
minus y1.
displacement. It will be the
Displacement, yeah.
displacement. Okay, so we call this a direction vector of the line. Maybe A, not Z. A. Okay, let's go back to the previous example. For these 2 points, find the direction vector. So example 4, continued. Find a direction vector. Jessica, are you working on the problems?
Uh, wait, so
Okay,
that's just basically just 0 slash 1 then.
okay. So it
Because
will
it's basically
be
1 minus 1 slash 3 minus 2. That's just a directional vector. It's just gonna go 1 up, I think.
okay. So you can see for this line, the slope does not exist,
But it goes up y for like every
but we can find the direction. The
yeah,
direction goes 1 up.
yes.
So the direction of lines, they are more general than slopes. Sometimes the slope doesn't exist, but the direction still exists.
So it doesn't, but for that line you're showing us, it has slope, right?
For this one, yes.
Okay, okay.
For any line,
Can we determine if the line has like, we could determine like if the line has a slope just by looking at its vector, right?
yes.
That's cool. So I can just
Okay,
talk to my math teacher and just say, we're using vector to determine if this line is like straight.
okay, so let
Boom.
O is A, B, be the direction of the line. Okay. If the first component of the direction of the line is not 0, then the slope is quotient of y over x, b over a. Okay. Okay, another one is beside the direction of the line, we have a normal
Hey,
vector.
hey. Oh,
Okay,
I hate
bless
allergy.
you. Oh, okay, me too. I mean, we have some, I understand. So a normal vector is a vector that's perpendicular to the line. There's a color over there.
Okay, so you're saying that if a does not equal 0, then you're saying the slope exists.
Uh-huh, yes. We use n over there. I will start here. So n.
Wait, are we gonna be using the slope for a function as well?
Okay, that will come later in college. It's called the derivative, not the slope. It's the generalization of slopes.
Aha.
Mhm. Okay, another notation. So first, we introduced direction of the line. Is where the line moves. Line moves in that direction. Then we introduce the normal vector. That is perpendicular to the direction of lines. Now think about it. Give a normal direction. Can you find a normal vector? Okay. The question.
Wait, can you go back up? I just want to check.
Okay. Is that enough? Or even
Okay. Nah, good, good, good.
okay. Given the 0, 1, find a normal vector. Okay, we will have 5 minutes break. Think about it. We'll continue from here next time. After the
Okay.
break, how to find a normal vector.
Okay.
Okay,
Is this vector the same with like the antagonist vector from minions?
okay. Think about it. We'll continue after 5 minutes.
This pick up on
Also,
me.
George, get a pen and a paper.
Okay, okay, okay.
Okay.
Hmm. 6 out.
Okay, we will start soon.
Wait, I have to go use the bathroom.
Okay, be quick. Okay. Okay. Don't know what this is, so let's assume.
Yo,
Okay, we don't know what this is, but what we want is the two vectors perpendicular. Is there any formula for this? When are two vectors perpendicular? Anyway,
when the angle is 90 degrees, I think.
and when the angles are 90 degrees.
When the cosine is 0, right?
Okay, so when the dot product is 0, so
Right,
we
but that's
want
only if there's another one.
n dot v. Okay, so this is our v, this is our n. What's their dot product? Amy.
Dot
Um,
product for that one.
Okay, I asked
zero,
Amy.
zero plus d.
That's just D, I think.
Oh, yeah, I know. But like,
But we want this to be 0. Right? What can we say about D?
it's equal to 0.
D must be 0. No matter what the C is, as
Wait,
long as
teacher.
D is 0.
Why George type Chinese in the chat?
Okay, let me, deleted.
No, not me. It was George. He just wrote some random Chinese stuff in the chat.
Okay.
I have a question.
Oh, yes, Amy.
So, like, the normal vector, it's like related to normal force, right?
Okay.
Like
Yes.
normal
Uh,
force, like the physics thing, yeah.
yes, yes, yes,
Okay.
yes.
Just
Yes.
checking.
Uh, so I'm not sure what you say is what I interpret in physics. You have to, if you like, we swing. If we swing something around the center, then there will be a force put into the center. So this normal force. Is that what you
Well,
have?
Um, sort of, maybe.
Okay,
Like I know
what's your
normal
normal?
force is just
Uh,
like perpendicular. And then isn't like the one with the circle, isn't that supposed to be called like centripetal force, right?
okay, okay.
Yeah.
Okay.
Which is
So,
also like technically normal force, but
okay. So the key point is perpendicular. It's perpendicular
Mhm.
to the direction of this.
Yeah.
Okay. And this is our what's our tangent line theorem, I think. We have a tangent line if and only if the angle is 90 degrees, right? Okay. So that's what we had before. This will be the normal force because
That
it's
doesn't look like 90
perpendicular.
degrees.
Mm-hmm.
It looks like you drew two lines.
Okay, I will erase this one.
Okay, that looks better. Hold on.
Okay. Okay. So it's a normal vector whenever d is 0. In particular, we can pick c to be any non-zero number. Pick Okay, I picked 1. Could you pick a different number, Amy?
Yeah.
Okay, if I pick -1,
Wait, what's C? Could you like,
C
because I mean,
is
like, I can't quite tell this apart.
Aaron, what's that?
Are you trying to write the example from above? Oh, wait, but then where's N? Which one's N? I mean,
Okay, if we pick -1, let's check. N is -1, 0. What's the dot product?
that's 0.
0.
This is
Okay.
basically just -1 times 0 plus 1 times 0, which is 0 plus 0, which is 0.
So this also works. I picked 1, Amy picked -1, both works. So normal vector is not unique. There are a lot of them. Okay, so give a line. We have the slope. We have direction. Now we have the normal vector. Okay. Next, we show a connection between the two with the 3. 0. We consider 2 lines. 2 lines, each one has a slope, direction. I write them separately, easier for you to see. M1, M2. Direction V1, V2. Norm, normal vector, N1, N2. Okay, so we have 2 lines. First line, slope M1, direction V1, normal direction V2, N1. Second line, slope M2, direction V2, a vector, and normal vector N2. Then we have we see the 2 lines are perpendicular. The 2 directions to normal vectors. two slopes. Okay. Let's draw a picture of it. Okay, so we have two lines. Each line will have slope. We have the directions. We have the normal vectors. We see the two lines are perpendicular. Okay. We can adjust this a little bit, make it looks better.
Can I just have some time to copy that down?
Okay. We will spend some time on this one. The two lines are perpendicular. It's equivalent to the two direction vectors, v1 and v2. They're perpendicular. Two normal vectors, perpendicular. m1, m2, the product of two slopes is -1. Okay. To start the proof, let's assume v1. Okay. Given the directions, we need to find the normal vector. How to find n1? We want to find a vector that is perpendicular to this one. What we can do is we will switch the two coordinates and then change the sign of the second one. Or to check, I call this how I get this. I switch the positions. Then I change this sign from positive to negative. Okay, let's verify. The dot product of the two is 0. Aaron, 0 or not?
Uh,
Amy,
Hold on. So that's basically just negative B1 A1 plus A1 B1.
Mm-hmm.
Uh, will that negative apply also to A1?
You tell me.
Oh no, then that is 0. Yeah, yeah. Because it's negative B1 times A1, which basically makes both of them negative. It's like saying negative 5 times 3. And then A1 times B1. Yeah, that's positive.
Okay. So you should be able to verify these two dot product will be 0. Okay. Based on what we did over there, could you give me a normal vector for the second line?
That would be negative B2 A2.
Negative B2, A2. You also verify B2 and 2 is 0. Okay, so that's the setup. Now we will prove. Two lines are perpendicular when the two directions are perpendicular. So this is the kind of geometry. They are perpendicular. The two vectors are also perpendicular. Kind of geometry. Okay, what does this mean? If we do the dot product of these two vectors, what do we get, Amy? Okay, Jessica, V1 and V2, what's their dot product?
Uh, um, one. Wait, no. I don't know.
Think about it. You know. You cannot say you don't know. I think you know. How do we do dot product?
Huh? Wait, what did you say?
How do we do dot product?
You it's the sum. I
The
think.
sum of the product.
Yeah. So it's 0.
So this will be 0. Okay. If the two vectors are perpendicular, now let's verify the two normal vectors. Are they perpendicular?
Yeah.
Okay. How? Why?
Because it's
Um,
B1
Okay.
negative and
Amy
then
first.
positive.
Amy first.
Okay.
'Cause it's like I'm trying to think of a way to explain this.
Okay.
It's like
Uh-huh.
negative. Okay, never mind. I think Aaron will explain it clearer.
Okay.
Um,
We can use this. Two vectors are perpendicular if their dot product is 0. Check. Okay, Amy, what's their dot product?
I
Okay,
can.
Aaron, you want to try. Okay, Aaron wants to try. Okay.
Okay, so it's basically negative B1 times negative B2. And that's basically just positive B1, B2. And then A1, A2, I believe.
Okay, why this 0?
Because it's, hold on, just a sec. Hmm?
If we simplify, we get B1, B2,
Yeah, and then plus
A1.
A1, A2. It's like the same thing for the other one, but it's 0.
Yes, yes.
Wait, so I like visualized it. What I did is like I took two vectors and I imagined that they're perpendicular, right? And then you put a normal vector on,
Mm-hmm.
and then they
Yes,
would eventually be like perpendicular. So it'd be like a
yes, yes,
square with like stuff. Yeah.
yes. That's correct. That's correct. What we did over here is essentially to establish that. So now we have a algebraic way to state what you just said. So, okay, to vector the perpendicular if and only if their dot product is 0. Okay,
Yeah.
now we verified this too. About this, how do we see about the slope? Why the product of the slopes is -1? Okay, so whenever we see the slope, we have an implicit assumption that A1 is not 0. Slope A2 is not 0. V1. Okay, so if we
Hey,
have,
teacher, I'm back.
okay, if we have the direction vector, could we tell the slope?
I
Who
mean,
remember
we could
this formula?
try.
Jordan, what's that?
We could try.
Okay, there's a formula for this. What's the formula? From direction to slope.
Then exists. If A is not equal to 0, then exists.
Okay, so what's the formula?
If A is not
M
equal,
equals, let me see, where was it again?
M1
M
equals
equals B
A2 minus
equals,
A1.
M equals B over A.
So that will be B1 over A1.
Okay.
Similarly, for the second direction, A2, B2.
I,
And that equals
So
B2, A2.
A2 is not 0.
That's B2, A2, I think.
B2 over A2.
M is the slope, right?
Yes, the slopes.
Oh, yes.
Okay. Y is the product,
Wait, this is actually
-1.
so cool. But isn't that just like X over Y? No, isn't that just over Y over X?
Yes, yes.
In
So
case that X is not 0.
you can treat this as the change of Y, change
Oh.
of X. This gives us the slope.
I mean, vector is cool, yeah.
I think it's because B1 times B2 over A1 times A2 equals 0, because like that's what we
Yeah.
proved in like the
No,
other
if
one.
those aren't equal, their product cannot be 0.
Okay,
Well,
so we
right,
will
yeah.
start from the equation we obtained over there, this equation, or
Uh-huh.
this equation. Either way, let me copy the equation. Proof A1, A2, B1, B2. Okay, we know that these two are not 0. So we will divide both sides by A1 and A2. See what you get. What's the first term if we divide it by A1, A2? Amy.
I am a little confused.
Okay, so we'll start from this equation. I will divide everything by A1, A2. Okay, if we divide by A1, what's left?
So you divide A1, A2 plus B1, B2 by A1, A2.
Mm-hmm.
Right. Oh, okay. So it's B1, B2 over A1, A2. Right.
So
Hmm.
this part goes to B1, B2, A1, A2. And this part goes to A1, A2, A1, A2. 0 over A1, A2. Okay, very easy. Now let's simplify. What's the first term? Aaron,
Let me think. That's just basically one.
it's 1. Okay, Amy, what's the last term?
It's 0.
0. Okay, we have one term left. How do we simplify this?
Uh,
Could we use this too?
that's gonna have to equal -1 because if it's 1 plus something equals 0, there has to be a negative. I believe.
Okay, let's see this part, the first half. What
That's
do you see over
M1.
there? Uh-huh.
Oh, it's M1 times M2. That's basically.
So the first part give us M1, second part M2. Then we subtract 1 from both sides. Okay, does this make sense? Any questions? Okay, Jessica, we started with the condition that the two directions are perpendicular. They're perpendicular to their dot product must be 0. We get our first equation. Then to check if the normal vector is also perpendicular, Amy has the geometric argument. So this is the corresponding algebraic argument. We find the dot product of the two normal vectors. It's the same as this one, so it's also 0. So we checked it is perpendicular. Next, we want to derive the relation between the slopes. We record our previous formula. Let me see where it is. We're over there. For any direction vector, the slope is the second component over the first component, b over a. We use this formula. So now we can remove this. For this direction, a1 is not 0. The slope is the quotient, b1 over a1. This direction, the slope is the quotient. The last step, want to verify the product of the two slopes is -1. Why? We start from this equation. a1b1 plus a2b2 is 0. We divide everything by the common factor of this equation. Now we simplify. Same thing, basically 1. 0 over anything is 0. Now, the first half we recognize is first slope, second half, second slope. We have this equation. Then we take the subtract 1, we get the result.
Wait, I have a question. How do
Yes.
you get 1 over A1, A2 anyway?
Okay. So initially we have this equation.
Yeah? Oh, so
Now we
you.
want to get to the slopes.
Mm-hmm.
To get the slopes, we need the quotient, right?
B1 over A1.
We can compare this. What do you have?
Uh,
To get the slopes from this formula, we will divide everything by A1 and B1, get the slopes.
Okay, so
Mhm.
so A1, A2 plus B1, B2 equals 0 divided by A1, A2.
Uh-huh.
Okay, I see.
See, we want to get the slopes. Okay, let's check. So the summary, for any two lines, if they are perpendicular, the dot product of the direction is 0. Dot product of the normal vectors is 0. However, the product of the two
So that's
slopes
algebra.
is not -1. It's not 0, but -1. So you can see the difference between product of numbers, dot product of vectors. The difference. So here, caution. If we have two numbers, let's use A, B is 0. What can you say about A or B?
Either one of them is 0.
One of them must be 0.
Well, yeah, but like the other one's just a random number.
Okay, now consider two vectors. U dot V is 0. What can you say about the two vectors?
Well,
That one of them must be 0.
no, that can't be used.
Okay,
Okay. We
Aaron, do
taught
you
that
have
in the last
examples?
class.
It does not mean. The example we had before, 1, 0, 0, 1. You can check. I get 1 times 0, 0 times 1 is 0. Dot product is 0. However, none of the vectors are 0. Okay, if I have 1, 2, I had in the very beginning -4, 2. Again, the dot product still 0, but we don't even have a 0 component over there. It does not imply any of the two vectors is 0. Okay, what does it imply?
The dot product is 0.
What does this imply? The dot product is 0.
Uh,
Geometrically, what can we say about the two vectors when their dot product is 0?
when it is 0. Uh,
Very simple. Maybe you overthink this. The
okay,
very
so
simple
like
answer.
basically just the what's it called? I forgot what it's called. Hold on, let me just check. Oh yeah, the norms. The norms times the cosine is equals 0.
it does imply.
That the norms times each other times cosine is 0.
Okay, you're getting very close. Okay, you see the difference between numbers and the vectors. If the product of two numbers is 0, one of them must be 0. If the product of two vectors with dot product is 0, it only implies they are perpendicular. It does not imply any one of them is 0. The difference. Another difference. If two numbers is 1, what can I see from here? What's the connection between the two numbers? Yeah, Amy.
They're like reciprocals of each other.
Reciprocal. B equals 1 over A equals 1 over B. Reciprocal. Now there's two vectors. U dot V is 1.
Then the dot product is 1. And then that means just that cosine times the vectors equals 1.
Okay. Does this imply they are reciprocal?
Hmm. Hold on.
Do we have okay, be very careful. There's no such thing for vectors. Okay, as an example, let's see. Let's compare the dot product UV and UW. Okay, Jessica.
Sorry.
Okay, Jessica. UV, what is the dot product?
Um, uh, wait. Um, uh, um,
Okay, Jessica, pay attention to listen to what I'm talking about, not doing other stuff. And Amy, your turn. How do you find the dot product?
The first one would be 3, 9 minus 2. That's just 1. And
Okay,
then the second one is 5 minus 4. That's also 1.
it's also 1. So we can see the same vector dot product with different vectors. We all get 1. If we had the reciprocal of U, so if we cannot tell. So this is another reason there's no reciprocal of vectors. Reciprocal of numbers and no reciprocal of vectors. Similarly, the product is zero. One of the numbers must be zero. The two vectors tend to be perpendicular. Okay, so the connection and the difference between numbers and the vector. We'll stop here and we'll continue next time. Any questions?
Okay.
Okay.
Thank you.